long ago, at a time when technology was very primitive.
People have many unanswered questions and unsolved puzzles.
And one of the many questions was,
why are clamshells on top of mountains?
as a result, after many studies and coming up with several theories,
Different parties of scientists disagreed and came up with different hypotheses.
the first party of scientists were the Neptunists.
Neptunus explained everything on Earth, including the seashells and improbably lofty places, by the idea of rising and falling of sea level.
This basically meant that the floods carried or washed everything away from its original position and deposited them elsewhere, and while doing so, the planet is being shaped by the constant state of erosion caused by the water. Thus, they explained that during floods, the water containing the shells would raise on top of mountains, and after the flood is over, the water level drops, but the shells remain in their place on top of mountains.
However, the opposing party who strongly disagreed were the Plutonists.
Volcanoes and earthquakes, among other enlivening agents, continually changed the face of the planet, but clearly owed nothing to wayward sea.
So, we ask ourselves, how can volcanoes have shaped the Earth? Well, volcanic eruptions are among the Earth's most powerful and destructive forces. Imagine hearing a volcano erupt thousands of miles away. Imagine looking through binoculars and seeing the top of a mountain collapse. Imagine discovering an ancient Roman city that had been buried in volcanic ash. Volcanoes are also creative forces. The Earth's first oceans and atmospheres formed from the gases given off by volcanoes. In turn, oceans and an atmosphere created the environment that made life possible on our planet. Volcanoes have shaped the Earth's landscape. Many of our mountains, islands, and plains have been built by volcanic eruptions, whether above or underneath the sea level. This is how volcanoes were able to shape the Earth's surface and landscape.
Later on came a new party of scientists with their own suggestions. They were the Uniformitarians. They believed that changes on Earth were gradual, and all Earth processes happened slowly over immense spans of time.
During the same period of time, Newton's theory played a great role, as it had fit in very well with how the world functions and has managed to prove and explain many unsolved mysteries. He believed that the heat within the Earth created new rocks and continents and thrust up mountain chains.
When Newton looked at farmland, he realized that soil was formed from the erosion of rocks, and particles of the soil were continually washed away and carried off by streams and rivers. So if this were the case all the time, the world must by now be worn very smooth. However, there are still mountains and hills. Therefore, after the earth is worn, there must be some process of renewal and uplift. Newton predicted that fossils raised with the mountains themselves, and as it is very clear in the animation, plates underneath the Earth's crust are constantly moving. At one point, those plates will collide. In doing so, they push against each other at such high pressure to the degree where they climb to higher levels on top of each other to form mountains.
Hence, geology.
All of those theories led to having to study rock divisions to find dates of certain periods.
These were the names of the periods.
Talk about the eras. Precambrian, Paleozoic, Mesozoic, Cenozoic. Talk about the period. Cretaceous, Jurassic, Silurian, Triassic. Oh yeah. Neolithic, Pleistocene, Miocene. Let's end this. Devonian, Desmonian, Cretaceous, Cretaceous,
From the outset, geologists tried to categorize rocks by the periods in which they were laid down. Reverend Adam Sedgwick of Cambridge claimed for the Cambrian period a layer of rock that at the same time Roderick Markinson believed it belonged to the Silurian period.
While digging into rocks, scientists started finding skeletons of animals that are no longer found. This opened a new field of interest or study, which were theories about extinctions of animals.
He believed that all the principal animal groups, reptiles, mammals, and fish, had coexisted since the dawn of time, and was confident that mammals would be found in the oldest phosphorus beds.
Catastrophists believed that extinctions were part of a series in which animals were repeatedly wiped out and replaced with new sets.
Furthermore, studying rock divisions opened up ideas for scientists to start theorizing about the age of the Earth.
Edmund Halley believed that to tell how old the Earth was, scientists needed to use a certain calculation.
This theory is called the salt clock theory. It is called so for the following reasons. Going back to the basics, we all know that when heat from the sun reaches the surface of the water evaporates into gas, which we know as clouds. The wind then pushes the clouds over mountains until the suitable temperature is reached, and the gas condenses into what we call rain. The rain then drains through the ground and soil, absorbing minerals, including salt grains, on its way back to the sea. When the rain reaches the sea, the salt is deposited. When this whole process is repeated again, and when the water evaporates, the salt is left behind. As a result, more salt is added to the sea. So what can we conclude from all of this? Imagine an initially fresh body of water in which salt is continually added. If a somewhat constant rate of accumulation of the salt is known, then a simple algebraic calculation would render the age of that particular body of water. It is now hypothesized that approximately if 1 cubic foot of seawater is evaporated, it will yield approximately 2.2 pounds of salt.
After Edmund's salt theory, George Lewis came up with a different approach.
This was a very basic experiment, from which the planet Earth was scaled down to a steel ball. This steel ball was then heated for a certain period of time. The metal sphere was then left to cool to reach a certain temperature for a certain period of time. So, if an object this big takes this amount of time to cool, how long would an object of this size take to cool? Thus, from the rate of cooling of a steel ball, scientists can extrapolate this to the larger Earth. Experiments took the form of heating up different sized balls of iron and timing how long they took to cool. Then it was a matter of extrapolating up to a ball of iron the size of the Earth and estimating the time needed for cooling. From this period of time, the age of the Earth could easily be measured.
The revolution of geology.